I think it might be time for another tour of the coolest laboratory at North Carolina State University. So let's take a look. This is the thermoluminescence and optically stimulated luminescence spectrometer. With this, I turn any ceramic into a radiation detector. I can also put the chamber under vacuum, or I can use a nitrogen purge. This is a very high precision saw. The blade in there is encrusted with diamonds, so I can do very, very fine cuts. And when I do that, I can take things like brick, like a core that I took from a brick, and you see all that particulate in there? That makes for great dosimeters. And I cut that into thin little slices, and then I can crush it in a nice little mortar and pestle like this, and then sieve it into different grain sizes with these sieves that allow me to then take all of those grains and put them into these tiny little cups that look like this, if I can focus it, which then goes into my thermoluminescence and optically stimulated luminescence spectrometer. Or, instead of putting it in there, I can put it into my electron paramagnetic resonance spectrometer. Oh, this is a beautiful little girl. She does magnetic resonance, basically the same kind of physics that you have with magnetic resonance imaging, or as it used to be called, nuclear magnetic resonance. And so this does magnetic resonance to also measure the same kind of signals that we have with TL and OSL. This little girl right here will actually do magnetic resonance. That's a signal that we have of a sample that we just looked at. And using magnetic resonance, we're also able to turn any kind of an insulator material into a radiation detector. Here I have a precision balance. We just barely moved it in here because we were doing some measurements that need to be done in the dark, so we moved it from the other room. And I can do very precise measurement of sample mass with that. Back here, normally it's not hidden. An optically stimulated luminescent spectrometer. It just basically measures gross photon light that's coming from dosimeters that look like these little things right here. Oh, you can't quite see it. There's a dosimeter used in medical physics. Also, throughout the lab, I have various electronics equipment. I have here a oscilloscope. I have power supplies. I have ohmmeters and a muffle furnace for annealing samples, one I can put under a vacuum. Various air monitoring equipment. This is for radiological air monitoring. We basically pull samples of air through filters like this, and then those filters can then be measured on an instrument that looks like this. And then the activity of the filters on the air that's pulled through those air filters, the ratio of that to the volume of air, these are basically precision pumps. The ratio of that is then the concentration of radioactivity in the air that was sampled. These instruments do alpha and beta spectroscopy. We're characterizing those for the Savannah River site. And then coming back around in here to the fume hoods, there's my storage locker into the fume hoods, where we've been doing some recent radiation shielding for electronics. So basically, you take the conformal coat that would normally be put onto something like a Raspberry Pi. This isn't quite a Raspberry Pi. There we go, the Raspberry Pi. You take a Raspberry Pi and you can put a conformal coat on it to potentially be able to shield it with stuff that looks like this. The conformal coat when you've got high metal oxide materials. This is what the conformal coat looks like when it does not have a high metal oxide conformal coat in it, or the high metal oxide in it. And this is what it looks like when you do. So it's got high metal oxide in the conformal coat that would allow you to potentially shield it for space applications. In this fume hood, I've got a student that's been doing some sample for ceramics. You see this cup? This cup was irradiated and it was a ceramic mug, and he's turning it into a radiation detector, an imager. You can see where my student have been doing some crushing and then some sieving and then a little bit of chemical preparation. This was for sandpaper, using the sand and sandpaper as a dosimeter. So there's a quick little tour of the lab. Coolest lab on campus. Plus I have this great view of the Gardner Arboretum right out here. Man, you gotta love that. Just a beautiful laboratory.